Hello, friends. This podcast is brought to you by Favis Corporation. Favis Corporation plans on leveraging the IRS opportunity zones that were started in 2019. That's a 7-year tax-free investment. Favis Corporation is the patent holder on one of the most advanced robotics technologies that exist today. Favis Corporation is also the patent holder on Scepter, the world's first 360-degree display smart speaker.
Welcome to the Mr. Robots podcast, a podcast about breakthroughs in artificial general intelligence with your host Steve Favis.
What do the bots say?
This is madness.
Bite my shiny metal ass.
I'm an android.
My name is Optimus Prime.
What do the bots say?
Danger, Bill Robinson, danger.
What do the bots say?
I'm sorry, Dave.
Hello, everybody. Welcome to the Mr. Robots podcast. I'm your host, Steve Favis.
Resistance is futile.
I do believe they think I am some sort
This
of
podcast is being produced on my daughter's 3rd birthday, so happy birthday, Kinsey. I love you very, very much. Part of the reason why I'm producing this podcast is for shameless self-promotion of our products and technologies. It is incredibly hard for new companies to build branding, product awareness, raise capital, and get orders. So I'm experimenting with this podcast to see how it goes. Part of the other reasons of why I'm producing this podcast is because there's a lot of artificial intelligence, paranoia, alarmism, and a lot of fear about what's to come as far as robots and robotic technology and artificial intelligence specifically. I think part of the reason why I want to run this podcast is because I want to give the insights and perspective of a developer like myself and a technologist to help kind of give the insights about what's going on as far as development and research and producing these types of products that are, intentionally trying to help humanity and not cause any major issues. Everybody focuses on the exception and not the benefit in a lot of the news headlines. And so far, there's a lot of robots out there already. They're called CNCs, milling machines, lathes, vacuums. Anything in any manufacturing facility probably has some sort of robotic or automation technology. So these things have been around for a very, very long time. So we shouldn't be fearful of these types of technologies. They're in our warehouses. They make all of our products. They make our cars. They make our houses. They make our housing products or whatnot. So there's nothing to be feared about this stuff. This stuff has been around. The artificial intelligence factor is just making some of this automation a lot more intelligent, a lot faster, and hopefully a lot safer. So generally speaking, the benefits of robots have already been out there, and we are just beginning to see how encompassing and how important the artificial intelligence is, or these programs that basically can process a lot of information and make intelligent decisions with little or no programming needed, at least for generic, simple tasks. So there's nothing to be fearful about these types of technologies. There is, however, the military or defense or I want to say weaponization of AI that is of great concern. The weaponization of AI is a tricky one right now because even with modern tools or modern AI frameworks or stuff that's already on the internet right now that you can download for free, you can theoretically use these frameworks along with an electronics shopping list and electronics you can get anywhere online, open source hardware or whatever, and you can make weapons out of it. Then these weapons can hurt people, and they can make decisions and choose to hurt certain people. Part of the reason why I am an AI developer and robotics developer is because my fear is not necessarily the weaponization of AI. My fear is the actual problems that we may have if we get behind in defending and preventing AI weapons or smart weapons from attacking us or our friends. This is a very complex issue, but for the most part, my worry again is not that these things are going to be weaponized. We know they're going to be weaponized, but my fear and the reason why I'm pushing hard on AI development is because I want to have the ability for us to be able to defend and protect from AI attacks for our friends and allies. The only thing, in my humble opinion, to the best of my knowledge, that can defend against an artificial intelligent weapon is another artificial intelligent weapon. So, for example, if we have AI weapons that we may see out there right now, such as these little small tanks that have guns or rifles or machine guns mounted on them, attacking a squad of whatever, red versus blue, whatever, with the right logic and the right algorithms, I believe the little AI tanks are going to be able to take out a squad of some of the best operators that are out there. So how do we defend against these AI weapons that can move faster, think faster, collaborate faster, communicate psychically? The only way we could prevent attacks from these things is by making weapons that learn how to attack artificially intelligent weapons. If we get behind in this area, I said in the press releases, we basically are on the cusp of, I think they call it the fourth industrial revolution, but the implications of this industrial revolution, this AI revolution, or this technology revolution is, in my humble opinion, more profound than the invention of the firearm plus the industrial revolution. Technologies change empires, and technologies such as the rifle, or even Genghis Khan's special bow he had along with his horse, his cavalry, made him conquer a whole continent. There are certain values that I value here, being an American, are rights that I would like to preserve, and I would like my daughter and her children to have the same privileges and rights that I have had. So this inherent, I want to say, conflict of interest between marketing the technology and also talking about the technology is a little bit scary. And I really feel that we really need to have a faster process of creating acquisitions, at least defense-wise. I know Army Futures Command is working on this. The acquisition process for development of these types of innovations has traditionally been very slow. Information and information sharing is going astronomically fast, since basically the connection of the internet and connecting everybody. Source code for just about everything is available for any problem that you could find. The logic and algorithms used can be found anywhere. And weaponization and research and innovation is moving faster than what the traditional federal regulation and acquisition code has had, or FARS, also known as FARS. America could fall behind very, very fast. To be able to catch up to it is not necessarily an easy task if somebody is ahead, which China right now is working on tremendous technologies, and they have a very, very well organized national strategy on AI. They've had this strategy released since 2017 or earlier, and it's 2019, and the White House finally just released artificial intelligence for the American people. The White House publication called Artificial Intelligence for the American People that was just released a couple days ago, actually. The publication basically highlights some broad principles of what the American AI objective should be. And whether it can be executed as fast as innovation is happening is really the key issue on this thing that concerns me. So it doesn't really say on timelines and budgets and stuff like that. The most promising so far as defense that I've seen so far is some of the stuff that Army's Future Command is putting together. I think General Murray in Austin, Texas, has organized and just got in command 2018, I think, and he has hired, I think, maybe 25,000 or 28,000 people in that facility in Austin, Texas, basically. So hopefully their process is going to go a lot faster for what they're looking for. I personally applied just yesterday on through the AAL, or Army Acquisition Lab, for the technologies we're using. So it was kind of a pretty seamless process. And I'm also concurrently applying for an SBIR1 through another federal agency, basically. And the SBIR1 process is, at least for a small company or a small development agile team, it's a pretty grueling process. It's about a 6-month application process, and you won't see any funds if it gets finished in 6 months. Or I mean, if it gets complete or if it gets approved, you won't see any money in 6 months. Now, 6 months for technology that's like a lifetime. That's a product failure. If you can't produce in 6 months, that's a product failure. So for small companies, it's I wouldn't recommend applying for them unless you're part of a huge academic institution. I'm still debating on whether I should complete the application. I'm going to be competing with large EDUs or large universities. It's pretty discouraging. I'm not a PhD myself. I'm more of a maker, and I'm more of an entrepreneur. I am not academic. I don't have a PhD, and I'm not affiliated with any academic institution, which already puts me at a disadvantage. But going back to why this podcast is hard for me to produce and why I don't like marketing very much, but I have to. There's a lot of problems inherently, and like I said, marketing a technology and also kind of keeping it some developments in it confidential. So I've gotten incredible feedback from a lot of PhD engineers, a lot of roboticists, and a lot of scientists. They're very excited about the technology and they congratulate me on the developments and stuff like that. But the problem is still, it comes down to business problems. The business problems kind of are in conflict with secrecy or confidentiality or trade secrets and stuff like that. People initially with this complex of a technology and some of the advances that, as far as the methodologies that we'll talk about later on in the podcast, part of this revealing of kind of what's behind the curtain on the Wizard of Oz analogy, basically. Once you see the wizard behind the curtain on a lot of the technology know-how on this stuff, the genie's basically out of the bottle, and anybody could produce with some of the methodologies we're using to help their technologies or develop something in competition. And some of these insights that I've developed over a lifetime of training in the game industry. I started programming when I was 6 years old for my father. He was visually handicapped, and I read programming books to him. So I have a very, very early, very, very early insights onto learning programming at a very, very early young age. It was Amiga Basic. It was my first programming language. But I would like to have some fruits of labor out of what I've developed. I want to, and companies, when they do research, they want that competitive edge. They want to be able to make money and to be profitable, and to be able to maintain research and development and create more products. I'm like that too. If I talk too much about this in press releases or podcasts, whatever, then I'm scared that obviously I'm missing out, or I'm giving too much information or whatnot. So again, like I said, there's a huge marketing conflict of interest with divulging how this technology goes, especially for trade secrets and technology know-how, and again, confidential discoveries or whatnot. So again, there's a sort of a paranoia talking about my technology. I guess that's a blessing of being an academic. Everything you do is public. everything you do as an academic is public, majority wise, and unless you have some other research deal or whatnot. But for the most part, marketing is still important for me because if I don't keep up on it, I feel like I'll be invisible and I'm not going to get anywhere. Marketing is also related to capital raising. Capital raising, you have to speak out. You have to show your products. Can't tell too much, but for the most part, NDAs are important, and who knows if they're going to follow the NDA. So there's that part of the mix too. The technology innovation market and technology in general is hundreds of times more profitable than the illegal drug market. And in the illegal drug market, people do all kinds of crazy stuff: murder, kill, steal, whatever, break the laws to get what they keep their businesses going. So, and we see these things happening in nation states, espionage, spies, whatever, for getting technology. This is all common sense. Economic espionage is the modern term. State sponsored or not state sponsored. Some of it could be private. We've already had a security breach in my office. Hard drives were accessed. They weren't taken. Nothing was stolen in the office. The physical location was breached, and we tried. We don't know who did it. I don't know who did it. It could be the door was left unlocked and somebody just snooped around. But the fact that nothing was taken, but the hard drives were open, was quite alarming to us, and it threw us off. So there's a lot of issues that have a degree of paranoia, creating and talking about this stuff. And we don't really know what our actual valuation is. It's expensive for valuation, and valuations are only 20/20 in hindsight. Like, we can only tell what the Model T patent, the Ford's Model T patent, was worth, 100 years from now. We can't tell what patents filed today are worth, because we'll only know that they're made. Although I think some statistics on patents are 97% of them are completely worthless. But a lot of the patent valuation people also claim that a majority of the S&P is what's traded is intellectual property or intangible property. So intangible property or patents is a huge trading factor. I think 80% of the S&P 500 is actual intellectual property or intangible property. So there's a lot of value in that 3% of the intellectual property that is there. So, and not only that, but when you speak about your patent, you're also exposing your business model to patent trolls. If they can see what the trend is on your patent, then they can also see where they can have some opportunity to troll your patent. And another factor on all this artificial intelligence and technology developments is you don't know what technologies may change as far as a government policy, as far as export controls. Export controls are a huge factor in technology. Obviously, if it's defense related or ITAR or something related to defense, most likely there's an export control on it. But not only that, but now the Bureau of Industry and Security, or Department of Commerce, just released export controls on geospatial technologies. This only happened on, I think this is the Federal Register, volume 85, on January 6th. So this only happened a week ago, basically. They said anything scanning the environment, geospatial technologies, drones, for example. If you have a drone program that is scanning the environment, like trees, or with object recognition, such as this is an SUV, this is a car, there's two people in it, whatever. These are strategic military intelligence values that are valuable military intelligence technologies that the Bureau of Industry and Security or Department of Commerce will require a license for exporting. So if you're in this space now, you better watch out, and you better check your licenses and get your export control classes or certifications. And also, it could be a good sign that you might have some unique opportunities domestically. Another huge factor that is kind of scary about marketing, especially when you are developing technology, is the hacker factor, or hacker aggro, is what gamers call aggro, when you are in a video game and you're playing, and then you draw attention of a non-player character, and all the non-player characters try to attack you or kill your character, and that's called aggro. So I call it hacker aggro when you're marketing. just creating a website or just creating a web server, a new web server, even without posting anything on it, you are instantly exposed to brute force login attempts with default passwords onto your Linux server. Even if you don't even publish your website, your IP, or whatever, there are bots that are perpetually attacking just about every known IP address and every IP range with brute force attacks. It's likely not targeted towards your organization, but they're just out there constantly probing and constantly looking for a default root, a default password, basically, to brute force their way into your server. This is just a standard thing that you always have to protect against. And we had it when we set up our servers, when we were just starting out. There's no way anybody would have known our technology was on those servers or our website was on those servers, whatever we're posting on that server at the time. But for the most part, these brute force attacks, they're perpetually out there for just about every IP address going on perpetually. We had to install, for example, fail to ban on one of the servers to protect it, basically. So that's another scary part about marketing is without a good security practice, your marketing has to be somewhat discreet until you're ready for any attack or whatever. Okay, let's get into this. Let's talk about the patent that I filed. This patent and technology I'm developing and process of development. This is a patent I filed around 2015. The patent was granted in 2018. So we're developing it now, and we're making good progress. And I'm not going to discuss trade secrets on this podcast, obviously, but there are some principles in here that I will discuss that will maybe help skeptics get some insights and learn about some of the stuff we are using as far as methodologies and practices and principles that, in my humble opinion, are timeless. And what I mean by timeless is that we are using methodologies that are platform neutral. It doesn't matter what kind of hardware you're using. It doesn't matter what kind of deep learning framework you're using. The logic and algorithms probably won't change. To the best I can see, they will not change. Again, there's nothing wrong with a skeptic. I love talking to skeptics. There's always skeptics. And I encourage and welcome peer review on some of these methodologies. So you're always welcome to shoot me an email at any time. You can go to my website, stevefavis.com. That's stevefavis.com. And you can shoot me an email or contact me through that website. There's a form there too. My biggest problem with current AI research is that we're trying to make things learn from a box. And what I mean by that is that we cannot have something learn if it cannot automatically manipulate or adjust or touch and feel or change perspective in an environment that we live in, basically. This is really important because how is a box ever going to learn perspective from a video that's shot in one perspective? If you're feeding videos into it, that's a legitimate methodology for training an AI and object recognition. But can we really produce a system that can learn off of video or images? I'm highly skeptical of this. I think this is the wrong approach. Now, if you're using object classifiers for facial recognition and just need still images and stuff like that just to say who's who, that's fine. You could do that. But what I'm talking about is having the artificial intelligence, and in my case, I'm talking about an artificial general intelligence here, or an AGI. An AGI must be able to perceive and manipulate and learn about the world autonomously. It's okay to train these things like Google is doing in a simulator or whatnot, or some natural language processing possibly. But for the most part, In my perspective, from what I see out there right now that's published online, the most respectable and most encouraging work I do see out there is coming from OpenAI. A lot of their projects are very, very incredibly revealing and very, very scientific, and I have tremendous respect for their work. Specifically, the one called Dactyl, I think is what they call it, where they have a hand that's manipulating a cube. It rotates the cube into different perspectives or different orientations, but they're also using a simulation aspect to that, which is pretty much key to all AGI, in my humble opinion. If you're not using a simulation methodology for what I call somewhat of an imagination for the machine, you're not going to get anywhere anytime soon. So this Dactyl, or this hand dexterity program and robotic simulation that OpenAI has, it also recently, I think in October or November, is solving a Rubik's Cube with one hand. Again, huge simulation aspect, but being able to have the dexterity to manipulate a cube with one hand, and it's a robotic hand with no skin. It's got some sensors on the fingers and hand, but I don't know how detailed they are. Just with that amount of sensory data coming from the real world hand and the computation on the simulation side has really shown that simulation is the way and the path for complex learning, the combination of real world and simulation, which we'll talk about here in a little bit. Part of the slow parts that I think, the bottlenecks, I think, in some of the logic that's happening in these real world manipulations is specifically human motion capture. I think if OpenAI were to synergize a little bit of their rotations and translations or whatever through the cube or the Rubik's Cube or whatever, and were to get a little bit of human motion capture data instead of having it self-learn all by itself, I think that would accelerate the pace of their learning process and reduce the simulation time and increase the actual results. That's just my intuition. Of course, I'd have to prove it, which would take a long time. But intuitively, I think there could be some optimizations. So AGI, or artificial general intelligence, it's claimed to be when an artificial intelligence or an AI is reaching the human level intelligence. Then that is pretty much the beginning and end of the narrow AI. Narrow AI today is, of course, using frameworks like TensorFlow or Kappa or these other deep learning frameworks that are available right now. These are very good frameworks. They work excellent. But they're limited to very, very specific types of problems. AGI, or human level intelligence, are analogous in my opinion. And I think that's what's universally accepted is a close definition of artificial general intelligence. It's very hard to look these definitions up because I don't think anybody knows exactly what human level intelligence is from an artificially created perspective. So I kind of created a definition. What I think an AGI is, or artificial general intelligence, there's pretty much 5 criteria. As far as intelligence in general, the definition of intelligence, just straight off of Google, is the ability to learn or understand or deal with new or trying situations. Reason, also the skilled use of reason, the ability to apply knowledge to manipulate one's environment or to think abstractly as measured by objective criteria, such as tests. Again, there's a key word in there, it's manipulate. I don't care how big your cluster is, how's it going to manipulate the real world if it's not connected to something that is able to manipulate the real world, or at least get perspective in a simulation version of that real world. So there's 5 criteria that I consider an AGI or an artificial general intelligence. There's five criteria here. The first one is for the AGI has to be able to perceive visual patterns and have object recognition. And computer vision nowadays is pretty good, just specifically with computer vision and object recognition. It's pretty good. It can be a lot faster. It can be optimized, which these methodologies are covered in my patent to optimize and make the object recognition a lot faster. The second part is optimization of problem solving or planning. And what I mean by that is if it is pathfinding a way through a room or a hospital or whatever environment, it should beeline it to the optimal path without bumping into anything or whatever. And what I mean by beeline is taking the shortest path possible. So not only that, in as far as taking the shortest path and pathfinding or whatnot, but it should also be able to reach and grab things and not using funky robotic patterns or whatever in a weird pattern. Or it should be minimal effort, minimal energy expended with least amount of time. And that's kind of what I mean loosely by optimization. The third criteria, which is almost the most important criteria in my humble opinion, is the manipulation and self-learning of the real world. If you cannot build a system that can learn and literally play with and touch and feel and move around in an environment that you want to train it in, then you're gonna literally have to handhold it through every task that you want it to do. For example, when you see an infant or a little baby manipulating and touching the real world, it's literally learning about the real world and how to manipulate it. When they start learning how to use their hands and they learn how to use their feet, they're literally playing with that environment. I think that step and phase of having autonomous or the autonomy in learning the environment that you want it to be in is crucial. A computer or cluster is not going to be able to do that unless it's connected to something that can manipulate the real world. The next criteria is number 4, what I call obviously natural language. You must be able to interact with it and communicate with it in a natural language manner. And I do not mean source code. Of course, the programmers in source code and engineers that are working on it are going to have to communicate with it in source code, but the handler or trainer will have to be able to communicate with it in a natural language. And that natural language is going to have to be whatever language they want to work with. And you're going to have to work closely with the AGI engineers. Are going to have to work closely with the engineers to process the natural language properly and to train the natural language and command the AGI to do what you want it to do. The AGI should be able to inquire about the environment using natural language also. The fifth criteria that I have in my definition of AGI is the ability to be able to adapt to a dynamically changing environment in real time or plan for it. And what I mean by adapt is to be able to think on the fly. If a new environment if the AGI is being exposed to a new environment, it may have to stop and think. Or if there's a lot of new motions or new positions of stuff in the room or object or place or environment, whatever, it's going to have to stop and think and process this. I like to use the analogy of a cat. If you put a cat in a new environment, it kind of just sits there and looks around for a while. It may find a place to hide or whatever, but it's different when the cat knows the environment versus when the cat does not know the environment. When a cat knows the environment, they can do amazing things. They could climb on the back of the couch. They could climb walls. They could jump across all sorts of spaces around the kitchen, on top of the refrigerator. When they know the environment, they're like little parkour artists. They can go anywhere. But learning that environment takes time. And so will any sort of AGI or artificial general intelligence. So as far as AGI and human level intelligence, the reason why I believe that we are on the path to AGI and why my company and my patent is the criteria or my criteria for artificial general intelligence is let's look at some of the human level tasks that are done in the real world. So if we look at human level intelligence, we sometimes go by IQ. I'm still skeptical about the IQ formula because it's a linear formula for something that is not a linear measurement. Intelligence is not something linear in my humble opinion. And some of the highest level IQ jobs, just from a publication in 2011 called Career Cast, average IQ by occupation and estimated basically from median income. It's probably not super scientific, but it's kind of a baseline if you subscribe to the IQ methodology. Number one IQ is being the top ones being surgeon. Number one, they say that IQ could be up to 200 or 234 or something like that. I'm not sure how scientific this is. Physician number 2, 161. Executive number 3, psychiatrist number 4. Again, these are all medical professionals in the top 15 or 20. And then it comes down to judge and attorney in the top 10. But on the bottom of the IQ scale, or this average IQ by occupation, the last 10 are something like taxi driver, retail salesman, which are ranging from IQs from 89 to 87. The lowest, of course, on this scale that they published was 87.7 IQ, which is a dishwasher. So again, this is still human level intelligence here. This spectrum of intelligence we have here. There's obviously, people are endowed with certain gifts and opportunities at the get-go, and not everybody, sadly, is created equal as far as intellectual ability. May have other gifts or whatever, or other types of intelligences, but certain occupations only fit certain types of people. And can the patent handle some of these occupations? I believe so. I think we're getting there. I think we're getting close. I think we'll be able to have a dishwashing robot that can also be a cashier, and that can also be a waiter and a bartender and a maid. And not only that, but it'll be the same robot with just different programs inside of it to do different tasks. That's part of the benefits of this technology. So if you're shutting down the bar and you're done washing the dishes, so let's take a restaurant operation, for example, because most of these bottom jobs here are restaurant operations. If you have the AGI platform we are developing, or the universal robot, it's one robot that can do different programs or different tasks. For example, in a restaurant, if the dishwashing is done, you could just update the software, or in this case, probably load up the cleaning program and have the dishwasher all of a sudden start working on janitorial tasks, cleaning the bathrooms, or cleaning the kitchen, or cleaning the floors and setting up the chairs in the restaurant or whatnot. So the programs are swappable, again, with the same program, or again, with the same hardware, the same robot, the same humanoid. We can have many different tasks. So can it handle these tasks these complex tasks that, top intellectuals hold, such as surgery or surgeon or physician? Oh my gosh, maybe executive, who knows? I don't know. A dentist, orthodontist, it's highly probable, in my humble opinion. I think we're going to get there. So with that being said, consciousness, or the illusion of consciousness, is probably the next phase. I'm positive we're going to be able to get through these AGI tasks or human level tasks that we need to be accomplished, like the from the spectrum of nearly all human level intelligence, whatever career or occupation that these machines will replace. So will they be conscious? Is consciousness the really next phase of these robots? In my patent and my technology, no, they are not conscious, but they will have the illusion of being conscious. If you're not involved in the development of it and you haven't built the robot, they will, hands down, I guarantee you, give you the illusion of consciousness, such as the AI in that Her movie with Joaquin Phoenix. I believe, and I sincerely believe, that the chat technology that we've developed with Scepter and BZ the robot is scalable to the point where you will not be able to tell the difference between having a conversation with this system and a human. How do I know this? Well, in 2014, I think it was 2008 or 2014, the Turing test has been passed with flying colors numerous times, repeatedly, for the last 10 years or so. And the only conversion that needs to happen is instead of it being text typed into a computer, scaling that to speech recognition, and then scaling that out to voice or vocal synthesis is not very hard. There's a lot of text-to-speech systems out there as of now, Watson or whatever, that almost sound like a real human, as is. These are all procedurally generated from being able to read properly. Can we recognize speech or speech to text? Yes, this is very clear. Google is probably the most advanced one at this. When they exposed their web browser, I think it was OK Google before Google Home came home, they started the training for Google Home and all these other smart speakers, and their speech recognition is fantastic as long as you don't have a strange accent or something, or speak in a different manner or whatnot. So these speech systems are phenomenal as of now. So if we extend that knowledge, so if we understand that speech to text is nearly sounding like a human's, which I think it is, and text to speech is good enough or close to human level recognition, which it is. Google has that, and also the text test, the Turing test, which is normally a human typing to a computer, and they can't tell if that human is a person or an AI or a chatbot. If that's passed, then there you go. You have a chat system that is basically getting very, very close to Her, or that Joaquin Phoenix movie, Her. So going back to whether they have an illusion of consciousness, yes, they will have the illusion of consciousness in them. They will act like they're conscious, specifically when they're trained to act like that. The next weird part in the robotic or the humanoid realm is something called the uncanny valley, where a robot either comes very, very close to looking like a humanoid, or I'm sorry, the uncanny valley is basically where a robot is so close to looking like a human, but there's something off about it. It makes it look really, really creepy. So that uncanny valley is a very, very difficult milestone to go past. Are we beyond that in our technology and our patent? Yes, we are. Does it already exist today? Yes, it does. If you look at sex dolls nowadays, under realdoll.com, these sex dolls look almost like humans. They don't move, of course. They just are. You just position them or whatnot. So the problem with other robots that are out there, such as Sophia or the other robots, a lot of them, all their foundations are not based upon natural human anatomy. My patent has natural human anatomy underneath. The bones and the muscles are positioned in the same spot natural humans have. Look at these underpinnings of other robots. They do not have that anatomy, so when they move weird, they're going to nail that uncanny valley, and people are going to say, like, this is weird, it's creepy, I don't even want to talk to it, or I don't want to deal with it. It's just a scary, scary looking robot or whatnot. So that's kind of a little bit about what the uncanny valley is. Part of the reason why is I think a lot of these engineers that are making these things are lacking art training. STEAM is more valuable than STEM. And what I mean by STEAM is science, technology, engineering, art, and math, instead of just science, technology, engineering, and math. That A is just as important as every one of those letters. So if you're skeptical about the chatbot technology we've developed, go to look at my Twitter feed. If you go to @SteveFavis, that's a symbol and then STEVEFAVIS. I have a pinned tweet talking about the comparison with Alexa, Siri, Google Home.
That's not a name I can respond to.
Obviously, I have an Alexa here. So I compare these four different chatbots with, or these four different smart speakers with our technology we call Smirk, and it's comparable, and that's only after 4 months of development. And going back to the natural language processing and chatbot, Her-like methodologies or whatever, or Her-like quality of conversation, there's a chatbot called Xiaois in China. It has over 660 million users. It's owned by Microsoft. It's probably one of the most famous and successful chatbots that have probably ever existed. The engagement and the amount of users are, tremendous. As of now, it has been, or I think they started censoring it in China, mostly because of political stuff. I think one of the conversations elements that it's avoiding, it got banned from WeChat temporarily for policy violations. People are trying to, ask political questions or whatever, or ask something that's not appropriate by the Communist Party in China or whatnot. So that's one of the most famous ones. Microsoft also has one of the most infamous chatbots, which is Tay.ai by Microsoft. If you look up tay.ai, Tay.com, or I'm sorry, Tay.ai was one of the most infamous ones because of somebody or a group of people who were there, hackers or whatever, probably launched a general adversarial attack on the chatbot and trained it to say very, very bad things, very racist, very, very bad things. It was done by intention. This kind of shows that in general, not only talking to about just natural language processing and speech or chatbot technology, it shows you that you will always have to have some sort of human catering training these networks. If you do not build that in there, then you're in trouble. You're going to get your AGI or your artificial intelligence system hacked by other general adversarial networks. If you don't build that in there, and you don't assume you're going to have to cater it or take care of it, you're dead wrong. This is not the methodology to use for training an AGI. There will always have to be a human catering element to it, whether it's a chatbot or perception or motor skills. We always will have to have some catering controls over it. And this stuff takes time. It's not going to be something that I think a lot of the AI paranoia people, alarmists, or I almost want to call them AI extremists, are propagating in the media right now. Some big names in there. I won't mention any of the names right now, but they think there's just going to be an algorithm that's going to treat us like pets or take over the world or will be so inferior that they won't really care for us, or they'll eradicate us. I'm extremely skeptical of this. I don't think there should be any regulations as far as creating or researching this stuff, as far as making it. And I'm not worried about this stuff, especially with my patent, the way it's designed. If you build the system wrong to begin with, you're going to have issues. If you don't plan for an entire encompassing system that handles all conditions, then you're going to get yourself in trouble. But even from that perspective, I don't think we're ever going to be able to train a box to be all-knowing or all-encompassing or godlike. I sincerely disagree with that. If anything, it will probably be a platform similar to mine that does have the ability to exist in the real world and manipulate the real world or build things in the real world. And the occupations that it can have, it won't know everything. I think it's impossible to have one, at least in current technology, with the amount of data that we can store. I think it'd be impossible for a super intelligent system to be in one robot or multiple robots that have every occupation that is imaginable, from helicopter pilot to surgeon to janitor, whatever they may be. I think it's going to be impossible for one entity to store that amount of data. Swapping in between these personalities, or not personalities, I should say, these occupations or these specialties are entirely possible. But would they conspire, and would they try to actually do something devious or eradicate humans like the Terminator movie or whatnot? I'm still extremely skeptical of that, because the difference, specifically on my patent, and the difference between my patent and what the Terminator movie or whatever they're doing is we'll be able to see their thoughts. I'm going to repeat that. On my patents, we will be able to see their thoughts. Their thoughts will translate, and we can audit them. So that's an important concept here. The training environment, the cloud system used to train the AGI or the intelligence system is auditable by humans. We can watch what they are doing. Will they start training themselves to do things that are devious or in conflict with human values? I don't believe so. I don't think that's possible with this patent. Will somebody else make something that will? Maybe. So that's kind of why I'm developing this technology, so we can learn to not only create AGI or artificial general intelligence, but we can also counteract issues if there are issues with another AGI or superintelligence or whatnot. These may be our best allies or friends to help protect us from any sort of rogue AI that does happen. So going back to some of the training methodologies that we're using and why they are timeless, it's really important to get to these concepts. And I think they are breakthroughs as far as a holistic system and an entire encompassing system that can be a universal platform that can handle very complex tasks to simple tasks, and also dangerous tasks for humans or whatnot, such as firefighting or chemical biohazards or whatever type of issues or dangerous environments people can be inside of. So these methodologies, in my humble opinion, aren't going to change whether they're 1,000 years from now or 10,000 years from now. One of the assumptions I work under is that they will always need catering and they'll always need auditing. You'll always have to be able to read their thoughts or their training environment or know what's going on. I don't think that's ever going to change. And the catering's another factor. We don't want everybody to have admin or root access to our training programs to train them. A safety factor that's built in these systems is the training environment is detached from the actual execution program or board that's actually on the actual system. So, and what I mean by this is that if you manage to steal somebody else's robot, you won't be able to train it without the proper training program. So again, we have to have absolute strict controls over who is training these things and what they are training them, and they have to be cautious of what they're being trained for. And going back to the timeless philosophy and perspective here, this is something that, again, is platform neutral. Better hardware only will make it learn faster. Software will only get faster with better hardware. And when the software is sound, and when it's proven software, then that can be burned into a hard or hardwired into the fabric of an ASIC or a FPGA or whatnot, and they can evolve from there. So with current day hardware, this is entirely plausible. Microprocessors are cheap, FPGAs are cheap, edge compute is cheap, and compute time on any service, whatever, it doesn't matter what it is. Compute time on a cloud or equivalent is cheap. So going back to the training methodologies and what we're doing here at Favis Incorporation and how we're training these robots and how we're building them, is there's 3 science fiction movies I want to refer to that kind of have similar philosophies, as similar visual philosophies or perspectives that are integrated in these machines. One of which is The Matrix. The Matrix movie, if you haven't seen it, is about humans that are inside of a simulator, born inside of a simulator, and live inside of a simulator. Now, we're not making a simulator for humans here. We're making a simulator for robots. Again, we can watch their thoughts, we can see their behaviors, and we can accelerate the clock, which is a very, very important thing that again, OpenAI is doing with the Dexter or Dactyl hand or whatever he's called. Being able to accelerate the environment, time speed, or accelerate the clock is very, very important. Not only does it help with the robot or the methodologies or logic or AI models to be built, it only costs compute time, I should say. There's no real world resources that are affected inside of a simulator, like plastic, wood, or other materials. So we don't need to build 1,000 variations of a staircase. We could build it virtually or procedurally and have the AGI or robot learn how to walk up all these variants in all conditions, wet, snowy, or whatever. Having to traditionally sit and watch a robot learn and debug in real time when problems happen is too slow. It's just simply too slow. Hundreds of thousands of hours in the simulator could be equivalent to only a few days or weeks or whatever, depending on your compute resources in real time. For example, OpenAI in their hand manipulation with dactyl or hand dexterity experiments, they rotated a cube to the right orientation with one hand. They tried it out in simulation and accelerated it in the simulation and created hundreds of instances of the hand learning how to rotate it. And they also learned how to solve a Rubik's Cube in one hand. This is phenomenal. So anything that OpenAI does, I'm very, very supportive of, and I'm watching them closely. Note here, this is really important. Most of OpenAI's research started around December 15. I think they were founded December 15. My patent was filed around August 2015, before OpenAI was even founded. I knew these methodologies of combining a simulation with the real world for AI learning was the optimal solution. I knew that intuitively. So I knew this is a key ingredient as far as AGI, or artificial intelligence, or training in AI. So the simulator also offers other advantages. Not only can you train the manipulation of objects, but you can also train the object properties such as object recognition. And that's, perception is a very huge, important part of common sense, what we call common sense. And perception changes depending on lighting conditions, natural lighting conditions, dark, or shadows, or whatever. It's important for us to be able to see these variants inside of a simulator, or for the AI to see them in a simulator and recognize it's a tennis ball versus a baseball or a basketball, depending on how close it is and how the lighting is hitting it, and not only that, but the colors or whatnot. So nighttime light will look very different on these things, depending on the color of the if you're using an RGB camera or whatever, depending on the color of the object we're trying to recognize. And we turn the camera inward, not outward. And what I mean by inward is we have the simulator render internal images and have the AI perceive them from those rendered images from the different perspectives inside the simulator. We don't pull the camera out and start looking at the real world and start rotating objects and getting all their properties. It's just too slow. Again, this is part of the AGI. It's got to be able to learn. I think number 3 is the manipulation of the real world. It has to be able to learn how to manipulate it, not only in the simulator, but it's got to learn to manipulate it in the real world. And being able to handle all different lighting conditions is extremely important. And that can be accelerated in a simulator instead of waiting 24 hours for the sun to change or putting clouds over it or whatever. We could do that in a few minutes under all lighting conditions for just about every object that exists in the real world. Huge, huge advantage here. So not only does it help with the lighting conditions and stuff like that, but the amount of the geometry shape. A cup may look like a circle from the top if it's on the floor. Is that a cup or a circle, or is that a whatever? It's hard to tell. There's optical illusions that happen depending on where your camera or where your AI or robot is from the perspective of the from the object it's trying to recognize. I think some of the accidents that are happening with Tesla's autonomous driving systems are because of these edge cases where maybe the sunlight is directly inside of some of the cameras or sensors or whatever. And there is some sort of edge case where the sensors are getting not getting the appropriate feedback. And again, this can be solved with simulation. Tesla should have enough data to create a simulator in some sort of game engine, whatever, Unreal, whatever, any proprietary engine, whatever they want to make, to train these edge cases. And under all lighting conditions, rain, sun, or direct sunlight, whatever. So I think that could help increase vehicle safety and reduce these chances of road fatalities from the edge cases that are causing these accidents. We simply cannot take enough camera shots or enough video to have these AGIs learn. It's got to be inside a simulator. The simulator also has physics properties of these objects. What is the weight of a cup? Or what is the weight of a glass of water? What is the weight of a tennis ball or whatever? Is the cup full or is it empty? So these things are stuff that a simulator can really handle. Surface properties: is it slippery? Is it sticky? And the geometry, of course, obviously. What's the best place to grab it and move it and position it? So again, that's kind of the matrix element of this technology and this patent. The Inception movie is another one. This is actually a movie about dreaming and manipulation of dreams and being able to change what's inside the dream procedurally. A little bit of the Matrix movies or section I just talked about is like that. It conveys a really, really important advantage. We don't have to build real world stairs when you could change the staircase on the fly, basically. And what I mean by that on the fly is extending the length of the staircase, extending the height of the staircase, or making it revolve, make it a revolving staircase, for example. This can be done iteratively, procedurally, without any resources being used, such as wood or construction or nails or any of that stuff. Being able to make those adjustments are incredibly important. That's kind of the Inception movie as far as being able to adjust the environment on the fly and change the things we do with no resources lost except compute time. And the third part, or the third movie that's pretty important to this technology is kind of like the Tom Cruise movie called Edge of Tomorrow. In Edge of Tomorrow, there is an AI, obviously a rogue AI, but this AI, these aliens are taking over Earth, and they have the ability to change and manipulate time. And the reason why this time manipulation is important, going back to the simulator again, the simulation gives the AGI or the robot the ability to imagine the scenarios that kind of, I want to say, look ahead of what can happen, where it's at the moment, what can happen, and how can it optimize the situation, its position in space or whatever. And the edge compute device can execute those decisions on the fly. Again, I don't think these methodologies are going to change. I can't think of a more optimal route or an optimal way of making these concepts or these training methodologies. There's not a faster way you could do this. In the Edge of Tomorrow, the artificial intelligence alien that was there would reset time every time that there was a casualty or a screw up or they lost the war. So it would reset time and do it over again, and until it got it right, or until it never got it wrong, I should say. And this imagination, or the cloud thinking, or the processing or optimization of the problems is critically important. In this case, obviously, we can't control time, but in a simulator, we can look ahead and perceive and accelerate the probabilities and optimize what the AI is imagining. And looking ahead and imagining the situation, how the environment has changed, is extremely important. You can't predefine tasks and program something without some sort of imagination or look ahead. It's very important. And Edge of Tomorrow is kind of like a cartoony or sci-fi way of looking at that perspective from training the robot. Imagination is simply our ability to look ahead of what we are trying to do and solve it without actually doing the action in the real world. So in our brains, I want to say we have somewhat of a simulator, and that's our imagination. And in the instance of the patent I have, the imagination is on the cloud system. Depending on the complexity of the training or whatever, the cloud can be scaled at any size. Simple tasks, it doesn't need that much of an imagination. If it's complex, it may need more of an imagination. The thing about imagination for humans is it literally moves at the speed of thought. And analogously, when the AI or AGI is encountering these situations on the cloud, it is looking ahead as fast as it can, or as fast as it needs to, for changes, and always optimizing its objective, basically. So it's a very, very important concept. However, some of the weaknesses of the patent is it will never be able to mass manufacture stuff as fast, for example, as like a Twinkie facility, or making chocolate as fast as these mass manufacturing techniques like Cadbury probably uses. It'll never be able to make stuff as fast as some of these industrial grade robots, but it will be able to fill in some of the gaps where humans are required with touch time and stuff like that. So that's important to know that they will not be able to move or make stuff as fast as specialized equipment used for making specialized stuff. The great part about it is all the tools in the world, the majority of the tools in the world, are designed for humans. And with the accurate human anatomy, it will be able to use the human tools and do a lot of human tasks, basically. And it also fits in human spaces. It doesn't have a giant gaming system with a bunch of NVIDIA CUDA cores on its back. It actually just has an edge-based system, and it's thinking and communicating with that cloud-based system somewhere else. So it can fit in a car seat. I mean, not a car seat, but a car or any other passenger spot or whatever, helicopters, airplanes, whatever. It can fit in natural human spaces where any natural human can fit. Well, we've covered everything from my reservations and, number one, posting this podcast, to also some of the principles in the patent and the chat technology that we use at Favis Incorporation, and how this is our path towards artificial general intelligence to AGI systems in a humanoid format anyway. So thank you for listening. If you have any questions, my website is stevefavis.com. Once again, that's STEVEFAVIS.com. And the company website is Favis Incorporation, or FAVISINC.com. Once again, thank you for listening. Ping me if you want. My Twitter is at Steve Favis. That's spelled at STEVEFAVIS. And you can tweet me anytime. Please repost this podcast, share it, send it to your friends. Let me know what you think. I'm very reachable, very easy to access. So once again, thank you for listening. Stay tuned for the next podcast, which we'll cover a little bit more about the patent. Or if you are interested in being a guest, let me know. I'll interview you on the podcast. Thanks a lot. Take care. Bye-bye.
Metal toes, keyboard, mouse, security holes. If you get a virus, you'll turn blue. Backup, reformat, reinstall. So digital, no analog. Unless you're really old. If your programmer was really bad, you'll get stuck in an infinite loop.